All right, so let's take a look at this next one. So here we're wanting to look at something kind of sort of like a Doppler effect. So even though the light travels at the same speed, and technically it's because the light travels at the same speed, we end up seeing a difference in wavelength and a difference in the frequency if we have a moving source of light, similar to how we hear different things when we have a moving source of sound. All right, and so lambda prime, our new wavelength, comes from our old wavelength, and we have this thing that kind of, sort of looks like what gamma was doing. It's both easier and more complicated, so it's kind of interesting. It's simpler in the fact that there are no exponents involved, but it's more complicated in the fact that there's, a full extra big fraction bar in here. We have 1 plus the ratio of the speeds over 1 minus the ratio of the speeds. So again, remember that take this and put it over C. Those are going to cancel, and we're looking at just the decimal number. And then the original wavelength here, 430 nanometers of light. We'll plug it in and see what happens. All right, so 430 nanometers. It's going to multiply by this great big square root of 1 plus 0.379 over 1 minus 0.379. It's up to you exactly how you plug this in. If you're comfortable with your calculator, absolutely you can run this in all at once. You may want to add these numbers, then subtract those numbers, divide them, square root, kind of run through order of operations. It's, again, personal preference and proficiency, whatever you're able to do. But if you work down this square root part, eventually you get this decimal 1.49017, so on, which is basically like a scaling factor. And so it multiplies by this 430, and in fact makes the wavelength considerably bigger. So we went from 430 to roughly 640 nanometers.